Hi and welcome to the Refinitiv Developer Community today, where we're going to be looking at part 7 of our tutorial, estimating monthly GDP via an expenditure approach and the Holt-Winters model. This is going to be quite long because we're going to be backtesting through the entirety of the model that we've created this far. So without further ado, let's get to it. All right, so to start with, we're going to be using some Markdown in order to delimitate exactly where we're at. So let's paste that in. Here, as you see, I'm using some hashtag in order to delimitate the fact that we are in a title. I'm going to be using a few little techniques like this to create some new lines, and then we're going to have some writing in order to tell you that we're going to be starting with January 2007. What do I mean by that? Well, we have our entire population data set, and that's the entire data that we've got from DataStream for GDP and its summands. And what we're going to have to do is tell the computer that we're going to be using a sample within our population data set that is going to be starting at 2007. So let's make that January 2007. And what we can do is that we can transfer this string that we've got, which we've delimited as start in memory with this inverted commas, into a datetime object. Now, you may want to do that in order to be able to manipulate the data that we have here. So here we've got the fact that it is a datetime object, 2007 January 1st, and we can convert it back to string if we want. That's quite simple, just simply with str in front of it. So let's use that. And you can see that I'm using this datetime library and strp time function with the start, so whatever string data that you're interested in, and we're just explicitly saying to the function the format in which you can see our date. Going forward from there, now that we know how to use date time, we can manipulate this data with datautil. For example, here I'm using month equal +1. So we're going to add a month to the data that we had to start with. At the start, it was 2007 January 1st. Now it's going to be 2007 February 1st. And we can use this and iterate through it in order to put ourselves in the shoes of an investor that's going to be trying to make a forecast for next month and then make an investment decision. The data that we have here, we can also transfer to string, just like we did before. And we can do so collecting only just the first 10 characters of the string in order to not have all of these hours, minutes, and seconds that came out of the datetime function. All right, so what we're going to do is that we're going to put in memory this +1 month that we've got from the start, and we're going to be using this in the Holt-Winters model that we're using now. So this is going to be our Holt-Winters estimate 1. We're going to be using the stats model Python library and the Holt-Winters exponential smoothing function that you can find in that library. The data set that we're going to be using is the data that we've got this far, .drop NA, because we've got quite a lot of data that we've collected from a data stream, including some NAs that we're not interested in. And here I'm using the lock technique with the square brackets technique in order to tell pandas that I'm only looking for data that goes from start +1 onwards. We're going to be using the additive Holt-Winters model with seasonal period of 12 because we're looking at months, and 12 months is a year. And damped is just a peculiarity to do with the Holt-Winters model, which is going to set that to true. What we're doing here is that we're fitting our model to the data set that we've got this far, the sample data set, going up to that start date, and we're making a single forecast. Now, when we do that, we can get a warning just like this one, and we can have a look at the forecast that we've got coming out. Now, there's only one forecast here, and as I said, we're only looking at one step ahead forecast, but you may be very well interested in more than that, and there's nothing wrong with just changing that one forecast, which here was 1 into 2, and here you see I've got _2 when I'm putting it in memory to remind myself that this is a 2-step forecast, and here it is right there. But as I said, we're going to try and actually put ourselves in the shoes of an investor who every month is going to try and predict next month's GDP and go from there, make investment decisions from there. That's just what this is written right here. So first of all, in order to do this, since we're going to be looping and putting ourselves in the shoes of an investor in the past, backtesting our model, we're going to be seeing all of these warnings coming up all the time. But these warnings are actually stopping our code. So let's dampen the warning messages. And then on top of that, let's continue with our code with start +2. So before we had start +1, and this is going to be start +2. So here you can see months +2. And again, we're only taking the first 10 characters, meaning that we're not interested in the hours and the minutes and the seconds, but only just the date itself. All right, so now it's going to be Holt-Winters estimate 2. Again, we're going to be using the additive trend, everything just as before, but now we're just using the start +2 as opposed to start +1. So our new forecast comes for not just, I think it's going to be March. April. There you go. April is going to be our new forecast for this right here. Now, there are several ways to collect this data because this is kind of stuck in this format. I used to do this. So what you can do here, for example, is if you take the string away from there, I'm converting this, which is, what is that actually? It's a pandas core series, and we just want the actual value coming out of it. So what I used to do is I used to convert it to a string like this, and then just collect the characters within the string that I'm looking for. However, there is a better way to do this that is more precise, and that's just using the dot values function that comes from the pandas series, and here it is right there. So you can see it is a lot more precise, but however, we don't need such a precision when it comes to date. So I just use the string concatenation method that we've been talking about this far in there. Okay, so going forward from there, what we're going to be doing is collecting everything that we've done this far in this 7th tutorial into one loop. So here I'm damping the warning messages so that doesn't come up every time, and I'm making some empty lists that I'm going to append later on with the data that we are collecting and creating, and I'm going to be looping through a index I from range 0 all the way up to the end of the data frame that we're interested in. Remember that we're doing drop NA because we've got quite a lot of NAs from all the data that we collected from data stream, and we're using this lock in order to let the computer know that we're going from the start. We're not interested in everything after the starting point because we're starting from there and then making forecasts from that point on. The only difference here in that code in comparison to the code before is going to be this piece right here, where I'm creating a cap. The reason for this is that the Holt-Winters model in Python sometimes can create some extreme values, minus infinity, plus infinity. We don't want that. Instead, what we're going to do is cap it and have it as just NAs. Going forward from there, we're going to be appending all of the lists that we've created above. So for example, here is one, and we're appending it with the data that we've collected. And here's another, that's the index for the data frame that we're creating with the new data that we've created. However, notice here that we're using data time and not strings. The reason being then we're going to try and plot the data that we've got, and it's just a little bit better to use data time. Going forward from there, whilst the loop is going through, at the end we're going to be trying to look at our data frame itself to see what we've gotten out of it. But whilst it's running, I just wanted to show you what we're going to be doing next, which is to say creating our own function, iterating through all of this. So let's have some markdown to delimitate exactly what we're doing. Here our loop is finished. We can see the data that came out of it. So that's the investment models in sample plus one forecast. So we're starting in February, and then we're doing plus one forecast iteratively through our dataset. Now what we can do is we can go through all that we've done before into one single function. And we're going to call this function like this. It's going to stand for In-Sample Recursive Prediction using the Holt-Winters model plus 1 out of sample period. So that's what all of these letters are for. By the way, this is version 3 because I've rewritten this function 3 times. And here, the latest thing that I've done is I've just created this datetime instead of strings in order to be able to plot our data better. But everything else is the same. Here you've got the cap just as before, and here you've got, for example, the lists that we're appending throughout. So if we put this into memory, what we can now do is that we can iterate through everything that we've done, but just with one function as opposed to just all of the code that we've written this far. Let's again use some markdown to delimitate where we're at. Here you can see that I'm using 3 hashtags just to say that it's not a main title, but just a third main title, and we're going to be using the function this time that we've created to go forward. We're still going to have to tell the computer where we're starting from. Now, you don't need to rewrite that yourself. I'm just writing it here to make it clear, and we're going to be using our model with that function, just like I said, that we've created. Now, this can take a short while, so whilst it's running, I'm going to be going through the next steps, and I'm going to be doing this every time we use this function. Once that function is done, it's going to create this one pandas data frame that we've named like this. And what we'd like to do is merge all of this new data with a data frame we had before, this main data frame we had called df. And that's what this does here. We're using the pandas library and the .merge function with our data frame and that new data frame that we've got. Outer just means that we're not going to leave out any information, and this is just letting the computer know what we're exactly merging on, and we're merging on the dates because that's the date data that we had. Let's have a quick look. I don't think I've got this here, but let's go off-piste, why not, at our data. And you can see we've got quite a lot of data here because we've just merged everything together into one so that it's easy to work with. All right, we can also calculate the errors that we've done, and that's a good thing to do in order to just know exactly how good our model is. And we can then, again, merge the data frame that we've got with these errors so that we can have everything in one place. And for example, plot things just from that one data frame. Here we're using matplotlib with the function that we've created before called plot1ax, for one axis as opposed to two axes, and we have all of the arguments that we've created in our own function. So we can go forward and do exactly the same thing, but this time with government investment data. Let's use some markdown again, just to delineate where we're at. And we can just do everything in one cell, which is to say, have our model, then merge our data, get our errors, and then merge everything together. Then we can try and plot all of this data like this. Here you can tell that our model is working quite well because our predictions are going quite well through the blue line, the step data that we got from DataStream. Okay, we can do the exact same thing with our net exports, using some markdown yet again, and creating our model and merging all of the information into one data frame. Now, you might be thinking that it's quite a lot to put into one data frame, but actually, especially in Python, this isn't that much data. Let's change the way this looks. Let's just do that quite quickly. And notice how we're doing exactly the same thing. There's nothing new here with the new summands of the GDP forecast that we're going to be creating. We're just merging everything together and just creating a very quick plot at the very end to have a look at each summand themselves, as well as the forecast. And you can see that our forecast just goes one step ahead. It really doesn't go much further. Now that we have all of our forecasts in summands, we can put them all together, and here are going to be our full GDP estimates. We can create them just by adding all of the data that we've had this far. So here we're going to be creating this new column called computed GDP in the data frame df, and we're going to be adding each of the columns from consumption, investment, as well as government data and net exports. So here, if we run this cell, we can try again and plot our data to have a look at how it looks. And we can see that, again, our model seems to be working quite well. Maybe even finding intricacies before they're published. So here you can see that there's a little dip that happens before it's actually realized. So is our model too good? Well, we'll see. That's something that's quite good about this Holt-Winters model, is that we're trying to do some interpolation here. So maybe we're going to be seeing some intermonthly behavior that you would not see otherwise, because data such as GDP is published with very low frequency, so you don't have data intermonthly. And here what we're doing is interpolating it ourselves. And you can use this data yourself. Here you see you've got it all into one neat data frame with every column named appropriately. And you can use this and go forward as an investor and make some investment decisions. All right, I hope you understand now why it's so interesting and important maybe to use macroeconomic data to make investment decisions, and why, as a result, this Holt-Winters model is very powerful, but not as powerful really as Python or Codebook, in which you can code all of this, collect the data from DataStream, put it all together to get not only intricate high-frequency interpolations to see dynamics that you wouldn't otherwise in published data, but also to forecast and make investment decisions from there. All right, this was the last tutorial. I hope this was informative and you've enjoyed it. This was using DataStream. I'm going to try and make another one using the new Icon Refinitiv Data library in Python. And do let me know if you have one specifically that you'd like to see in a tutorial in our Q&A. You can find our Q&A on our developer portal on the top right there. All right, thank you. Have a nice day.